Hi class, today we are going to do Unit 1, Lesson 3. We're going to study another type of special right triangles, and it's called the 30, 60, 90 triangle. So by the end, hopefully you can find exact measurements of the sides of 30, 60, 90 triangles. Find the height of this equilateral triangle. So think about, what do I remember about equilateral triangles? Well, if it's equilateral, all the sides are the same length, and all the angles are the same size. What we're going to try to find is the height of this triangle. So imagine the height. It's going to drop down like this, and it has to be perpendicular to the base. Now, if this is an equilateral triangle, if you take 180 and divide by 3, you get 60, which means each of the angles has to be 60 degrees. But that height is going to bisect that angle up at the top of this triangle into two 30-degree angles. Also, it's going to bisect the base that it's perpendicular to. And so if the left side is x, the right side would also be x. Now the length of this whole side is 2x. And it's an equilateral triangle, so this side is also 2x, this side is also 2x. Remember, what we're trying to find is the height, so I'll call this h for height. All right, let's try to do that. Let's do something similar to what we did yesterday. Let's use the Pythagorean theorem. So imagine we're just going to use half of this equilateral triangle. And why is that? It's because I get a 90-degree corner in one of the corners of the triangle, which makes it a right triangle. And when I have a right triangle, I can do the Pythagorean theorem. So I'm going to do a squared plus b squared equals c squared. Now the x and the h are my a and b. So x squared plus h squared. The c is 2x. You want to put that in parentheses because you have to square that whole side. There's nothing I can really do with x squared. There's nothing I can really do with h squared. But the 2x squared, I can sort of think of it as distributing almost. I'm going to square the 2 and I'm going to square the x. So I have x squared plus h squared equals 4x squared. Get your like terms together. So you're going to want to subtract your x squared over to the other side. You'll be left with h squared equals, and think about 4x squared minus 1x squared is 3x squared. We're trying to solve for the height. So instead of having h squared, I want to just have plain h. So I'm going to take the square root of both sides, and I'll wind up with h equals, now the square root of 3 is not a nice number, so I'm going to leave that under the root sign, but the square root of x squared is x. The square root and the square sort of undo each other, cancel each other out. So the height of this 30, 60, 90 triangle that you can see right here would be x root 3. So think about what you just learned. You just learned if you have a 30, 60, 90 triangle, the bottom of that triangle we could call x, the height we could call x root 3, and then look at the hypotenuse. The hypotenuse is 2x. All of these sides have an x on them, so what if we divide all of them by x? Well, down here on the bottom, you're going to get 1. Here on the hypotenuse, the x's will cancel, you'll get 2. And here on the other leg, you're going to have the x's cancel, and you're going to get root 3. So what you just figured out is in every 30, 60, 90 triangle, the sides have a ratio of 1 to 2 to root 3. So let's think about this 30, 60, 90 triangle. The shortest leg is across from the smallest angle. So your smallest angle is 30. Go across from that, you'll have your short leg. The short leg has a ratio of 1 to 2 with the hypotenuse. Remember, the hypotenuse is always across from the 90-degree angle. So this is your hypotenuse. It's the longest side of your triangle, which leaves the root 3 over here for on the longer leg. The long leg is across from the 60-degree angle. Okay, so let's use that proportion of 1 to 2 to root 3, and let's see if we can do example 1 part A. So we're dealing with DE and EF. DE and EF have a ratio of 1 to root 3. We have the 12, we need EF. So similar to our lesson on 45, 45, 90 triangles, we can set up a proportion and we can cross multiply. And so in this case, when we cross multiply, we're going to multiply 1 times x and 12 times root 3. And so we wind up with 1 times x is x and 12 times root 3 is 12 root 3. So EF equals 12 root 3. Let's try our next one, part B. This time we're working with DF and DE. So find them on the picture. DF has a ratio of 2 to 1 with DE. The hypotenuse is twice as long as the short leg. So 16 over x. Cross multiply, you get 2x equals 16, x equals 8. So DE in this case would equal 8. Please take a minute and put the ratio numbers on the sides of this triangle. So if you put on the 1, the 2, and the root 3 like this, you should be good. Now we're finding the ratio of DF to DF to EF. So DF is 2, EF is root 3. And we know DF is 8, and we don't know EF, so we'll call that x. Cross multiply. You get 2x equals 8 root 3. We're trying to solve for x, so divide by 2. And then x equals 4 root 3, because we can divide 8 by 2, and so that is EF. Why don't you go ahead and pause the video and try part D. So our ratio of EF to DF is root 3 to 2, and then we have 12 over x. Cross multiply, we get x root 3 equals 24. Divide by root 3. And we cannot leave that square root of 3 on the bottom of the fraction. We need to rationalize the denominator. We're going to multiply by root 3 over root 3. So you're going to get 24 root 3 over regular 3, root 9, which turns into regular 3. But 24 divided by 3 is 8. So it's really 8 root 3 equals DF. Again, pause the video and try to label the sides with the 1, the 2, and the root 3. See if you can get them in the right spots. All right, that's how they should be labeled. We're working with JK and JL. JK and JL have a ratio of 1 to 2, so 3 root 3 over x. Cross multiply, we get x equals 2 times 3 root 3, which means x equals 6 root 3. So JL is 6 root 3. Why don't you guys pause the video, try parts B and C, and see if you can get those. KL and JL have a ratio of root 3 to 2. And then 8 root 3 we don't have the other one. Cross multiply. So you're going to get x times root 3 equals 2 times 8 root 3. So x root 3 equals 16 root 3. Divide by root 3. I like what happens here. They cancel on the left, they cancel on the right. X is 16, so JL is 16. And the last one, we're working with JL and KL. So JL is 2, KL is root 3. So we have a ratio of 2 to root 3. And then we have 6 root 10, and we want to find the other one. Again, cross multiply. So 2x equals 6 root 10 times root 3. 2x equals 6 root 30. Divide by 2. x equals 3 root 30. And I don't think any perfect squares divide into 30. And so that's it. KL equals 3 root 30. Example 3, solve for x and y. So we can see we have two different special triangles here. We have a 45, 45, 90 and a 30, 60, 90. And we're going to have to use one to find the values in the other. So first, I want you to do this. Solve for a side that the triangles have in common. So number one, solve for a side that the triangles have in common. So in this case, I think we're going to start by trying to solve for this side right here. I kind of highlighted it in red. So we're going to have to work with the 8. And the 8 is on a 45, 45, 90 triangle. And so remember from yesterday, a 45, 45, 90 has a ratio of 1 to 1 to root 2. So if I know the 8 and I want over here, I think the ratio that I'm going to work with is root 2 to 1. I know the 8 and I want to find the leg. Cross multiply. So we're going to have x root 2 equals 8. Divide by root 2. Can't leave a root on the bottom of the fraction. So we're going to have to rationalize the denominator. So we're going to get 8 root 2 over root 4, which is 2. And then finally 8 divided by 2 is 4. So 4 root 2. So that 4 root 2 is the length of this leg. I'll put a little blue here. Now we can use that to find x and to find y. So second step, number 2, let's solve for x. So now I'm going to use the triangle on the right. And the triangle on the right is a 30, 60, 90 triangle. And remember, the ratio of those legs, the short leg gets the 1. So across from the 30, this gets a 1. The hypotenuse gets a 2. And the long leg gets a root 3. And so if we're going to try to find x, we're going to be working with the 1 and the root 3. So, I better use darker color. So 1 to root 3. And then 4 root 2 over x. Cross multiply, you get x equals 4 root 2 times root 3, which is 4 root 6. And so x equals 4 root 6. Notice all of our answers today, again, we want exact answers, no decimals. Step number 3 is going to be solve for y. Now our triangle is already labeled, and I'm going to use that 4 root 2 again. So the 4 root 2 has a ratio of 1 to 2 with y. So a ratio of 1 to 2, and then I have 4 root 2 and I need y. Cross multiply, y times 1 is y. 2 times 4 root 2 is 8 root 2. So y equals 8 root 2. Example 4. This time you'll notice we have two 30, 60, 90 triangles. This would be 30 degrees and this would be 30 degrees. We're supposed to solve for x. You're going to start by finding the side that the triangles have in common. And so we have to start by finding this side. And we're going to have to start where we have a number, and that is the 10 for the hypotenuse. So let's think about this triangle on the left. In the triangle on the left, the ratio of the sides, down here's your 30 degrees. So if you go across, this would be our 1. This would be our 2 because it's twice as long. It's the hypotenuse. And this would be our root 3. So if we're working with the 10 and we need to find this side over here, the long leg, our ratio is 2 to root 3. And I know the 10 and I need to find, I'm going to call it y. I'll call it y over there. Cross multiply, you get 2y equals 10 root 3. Divide by 2, you get y equals 5 root 3. So 5 root 3 is the, well, let me just erase here and I'll show you on the picture. So 5 root 3 is this side right here. Now we can use the 5 root 3 to get the x. So let's label our sides in the other triangle, the triangle on the right. Here's our smallest angle, go across, you get your short leg, that's your 1. Your hypotenuse is actually across from the 90, so that's over here. Your long leg is over here. So we have the hypotenuse and we need the long leg. So our ratio again is 2 to root 3. The ratio goes 5 root 3 to x. And so now we cross multiply. When we cross multiply these, we get 2x. When we cross multiply 5 root 3 times root 3, it's actually 5 times root 9 or 5 times 3. So we have 2x equals 15. Divide by 2, x equals 7.5. Or if you'd rather, you can leave it 15 over 2. Both of those are considered to be exact answers because neither one of them has been rounded. Number 5 is our last example in the note, so will you please pause the video and try number 5 on your own, and then if you get stuck or when you're done, unpause the video to see if you got it right. So I'm going to label my ratio numbers on this top triangle. And I can see the ratio of the sides is 1 to 2 to root 3. And I have the 6, and I want to try to find this side that the two triangles have in common. So my ratio that I'm going to work with is root 3 to 2. And I have the 6, and I want to find, I'll call it y. This is going to be our y. So cross multiply, you have root 3 times y equals 12. Divide by root 3. Can't leave a root on the bottom of the fraction, so you multiply by root 3 over root 3. You get 12 root 3 over root 9, which is 3. And 12 divided by 3 is 4, so you have 4 root 3. So in other words, this side is 4 root 3. Now we're going to use that to find x. Now in x, we have a 45, 45, 90 triangle. And so think about the sides in a 45, 45, 90. Their ratio was 1 to 1 to root 2. And so we're dealing with a ratio of 1 to root 2. Highlight those two sides in red. So we know this side and we want this side. And so again, you can see the 1 and the root 2. And now I have the 4 root 3 and I want to find x. And so then I say equals 4 root 3 over x. Cross multiply, x times 1 is x. 4 root 3 times root 2 is 4 root 6. And 4 root 6 is x. Next, will you please try Unit 1, Practice 3. If you get stuck or need help, send your teacher a little Schoology message. Have a great day.